Okay, so this lesson is on piecewise functions. What are piecewise functions and how do we use them? A piecewise function is made up of two or more functions, each with its own separate domain. So what this is an example of a piecewise function right here. This part right here, the 2x plus 3, we use that piece only when the x value that you're plugging in is greater than or equal to 1. If it's not that, in other words, maybe your number is, let's say, 0, so it's less than 1, then you use this piece instead. So you really are determining which piece to use by the domain. And so they're separate pieces, thus the name piecewise function. So let's say a gym owner wants to purchase custom wristbands for a marketing promotion. She thinks she will need about 75 bands. Her assistant insists that ordering over 100 wristbands is going to be less expensive than ordering 75. Is this accurate? Okay, so let's say we do order 75. Okay, 75 times, now according to this, 51 to 100 wristbands is $1 a piece. Okay, so that gives us $75. Okay, and it also says I need to add $10 shipping. So that brings me to 85 bucks. Okay, so now what if we do the other one here? We try maybe a different number. We go more than 100. Let's just do like 102. We multiply according to this, it's 50 cents each for anything over 100. So times 50, or 0.50, excuse me, then that would be $51. Plus my shipping is free, so I'm looking at just 51 bucks. So definitely her assistant is correct. It's gonna be cheaper if you order over 100. Okay, since there are different rules for this, or different rates for different number of wristbands, this function is called a piecewise function. Really, this part right here is kind of my domain because that's my x value, the number of wristbands. So this is a piecewise function. Okay, we can evaluate piecewise functions, and when we do that, you first need to decide which piece to use by looking at your domain. So let's evaluate and let's try this for this function here. It's got 3 pieces, and here I want to look at this very first one. It says f of negative 8. Well, I have 3 pieces. This one says when x is less than negative 2, I'm going to use that piece right here. Okay. The second piece says when x is between negative 2 and 5, I'm going to use this piece. Okay. And then when x is bigger than 5, we'll use this. Okay. So negative 8 is definitely in this section right here. Okay. So then it just says, well, if it's less than negative 2, you're just going to say it's 3 then. Okay. Cool. So that was easy. I know that my answer was 3. Okay, so let's go over here to f of 3. So I want to pull f of 3 is in between. It's the middle one. So then it says I need to take my value for x, which is 3, and add 2. So x plus 2, my x is 2, so I'm going to say 3 plus 2. Which would give me 5. So f of 3 is 5. So you're just plugging into the appropriate piece and doing whatever they tell you. All right, negative 2. Well, negative 2, this one says you got to be less than negative 2, so it's not that one. I'm going to use this piece again. So this would be negative 2 and then plus 2, which is 0. Okay. And then 5. Okay, f of 5. Well, that's still in this one right here. So I'm just going to add 2 again. So that'd be 7. Okay. Now I got 0. And again, that's in the middle piece. It's between -2 and 5. So that would be 0 plus 2. Okay, and then the last one is f of 10, which is definitely bigger than 5. So I'm going to use this piece, so 4 times 10, which is 40. And that's how you evaluate a piecewise function. Look at the domain, figure out what you got to use, which piece you got to use. Okay, graphing. Now, these are slope-intercept form, right? Both linear parts. It says x plus 1 when x is less than 4, and then -3/2 x plus 6 if x is greater than or equal to 4. Okay, so I'm going to plot this first one, and I'm just going to do the whole thing and then do some erasing. Okay, so my y-intercept is 1. Okay, my slope, right, is really a 1 there, so that would be a rise of 1 and a run of 1. I might do this a couple of times, maybe even the other way. Okay. So here we go. Let's draw, I'll zoom in a little bit and draw my line. Okay. That's pretty good. All right, now it says I want to keep this when x is less than 4. So 4 is, when x is 4, is right here. So I want to keep everything less than 4. So that means I got to get rid of this part over here. So let's do that. I'm going to erase. Okay, now it's less than 4. So that means at that spot I need an open circle right there. I probably should extend this a little further. My line really should be okay. All right, now the other part, now I can graph the other part. I'll do that in a different color. Let's do it in purple. Okay, so my y-intercept is 6. Okay, the slope is -3/2, so down 3 and over 2. So I'm going to go down 3 over 2, down 3 over 2, maybe down 3 over 2. Just a few times, make sure I got it. Okay, so something like that, right? That's that line. But it says I want to keep that only when x is greater than or equal to 4, which is right there when my x is 4. So I'm looking at, here's this line where x equals 4. I want everything to the right of that. Okay, so I got some erasing to do again. I need to keep the right part of it. I need to get rid of this part. Okay, and then this, I guess that works. Not quite as cool as I wanted it, but we'll go with that. All right, so you can see the two pieces there, and we've graphed it. So then it asks, when is the graph increasing? Well, the graph is increasing in this section right here. So that would be when from -infinity to 4, and then like that. And then when is the graph decreasing? That would be from 4 to infinity, right there. And that's how we do a piecewise function and graph it. Okay, let's try this another time. This one has 3 pieces, and then we'll try to see if we can write a piecewise function of our own. Okay. All right, 3 pieces. I've got 2x, negative x minus 1, and then negative 3. Okay, so 2x. This is the same as 2x plus 0. So I'll do this one in orange since I'm already there. That means my y-intercept is 0. And I'm going to go up 2 and over 1 is my slope. Okay. And then that's for x less than or equal to negative 2. So I'm going to make my line here. Okay. Now, I want to erase some of this. It says when x is less than or equal to negative 2. So the line right here is negative 2, right? I want to keep that, everything to the left of that line. So I got to get rid of some stuff here. Okay. And then it's less than or equal to, so that is a closed dot. There we go. We've graphed that first piece. All right. Let's try blue for this one. Okay, so negative x minus 1. I want to start with my y-intercept of negative 1. My slope is in front. There's really a negative 1 there, so I'm going to put negative 1 slope. That means down 1, negative 1 over 1, right? So down 1 over 1. And okay. All right. Now I'm keeping it between negative 2 and 4. So negative 2 and 4. I want to keep everything in between those 2 lines. So I'm going to erase there, and then 4, anything past 4. Ooh. Okay, now it says less than, so I think I'm gonna need some open circles on that one. So give me myself a little room here. Do open, open, there we go. All right, and then lastly, we'll try this one in green. It says when x is greater than or equal to 4, we just do negative 3. So remember, this is the same as saying y equals negative 3, which is just what kind of line? That's a horizontal line. So we just need to graph a horizontal line at negative 3. Okay. Okay, now I know it starts at 4 and goes greater than 4. So I'm going to use my maybe a little bit smaller eraser. We're just going to erase a little bit of there. And then, let's see, it was greater than or equal to, so I want closed dot. There we go. So notice this is 3 pieces here we've just graphed with different domains. Again, a piecewise function. When is the graph increasing? So that would be right here. So that's from negative infinity to -2. When is the graph decreasing? I guess this should be a bracket. -2 is included. From -2 to 4. And then that's it. Because the other part, it's not, the last part is not going up or down. All right. Okay, writing a piecewise function. This can be a little tricky. We just need to remember slope-intercept form is y equals mx plus b. Remember, m is your slope, your b is your y-intercept. So I like to find the slope of each piece first, and then find the y-intercept. So I'm going to call this first one f of x. I have 2 pieces. Okay. All right, so this function right here, it looks like I have a dot here and I got a dot here. So that's down 1 to the left 1. That has -1 over -1, which would be a slope of 1. So 1x, or we could just say x. And then my y-intercept is 3. So x plus 3. Now it looks like I only do that function from 0 to the left. So this would be when x is less than 0. I know it's less than because right here is an open circle. Okay, let's do the other section. So this one, I got a point here, and then I have a point here, which is up to and over 1. That's 2 over 1, which reduces to 2x. And then my y-intercept is -1, so -1. And that would be when x is greater than or equal to 0, since this function is from here to over, right? Okay, and then, whoops, that's not my eraser. There we go. Okay, so I hope that makes sense. Now let's try this one more time over here. We'll do this one purple. Call this g of x. Okay, so this function right here is, it's got a slope of -1, so right, it looks like up 1 and to the left 1, which would be it'd be 1 over -1. So that's -1. And then my y-intercept here is -1. And again, this is when x is less than or equal to 0. From here to the left for that piece. Okay, and then this function right here, or that piece of this function, has a point here and a point here. It looks like up 1 and to the right 1, which would be 1 over 1 is 1. And then my y-intercept is 2. And that's when x is greater than 0. And that is it. All about piecewise functions. I hope that makes sense. Go ahead and give the assignment a try. See ya. Bye.